So guys, let me share my screen. Okay. I'm just waiting. Do you guys see my screen? Do you guys see my screen? Okay, great. So I'm just doing this for the first time. I'm not sure how does this work. So okay, so we are on live on YouTube as well. Okay. Great. So topic for today is full mesh and route reflector. Okay. Full mesh, route reflector. Okay. So these are the two concepts inside Ibgp. Okay. So let me tell you the default behavior of Ibgp, internal BGP, is a Ibgp speaking router will not advertise any other neighbors. That means, let's say I have 4 routers, okay, A, B, C, and D. So let's say I have one of Ibgp speaking router, okay, which is forming neighborship with 2 different routers. Now let's assume whatever network the router was advertising is going to remain just within these two of them. Okay, so there is no way the routers are gonna advertise this network over to this. Okay, so this is a default behavior of Ibgp, and what happens is we just lose the intermediate connection, because uh, so basically this router doesn't know what are these networks, right? So in order to avoid, or in order to fix this issue, we have two options. One is full mesh and the second one is route reflector. Okay, so we will first lab full mesh. I'll do the labbing, and then I'll show you the route reflector. Okay, so also let me tell you, these are the two method to rectify the Ibgp concern. Okay, and the drawback of having full meshes, if we just follow the BGP theory, the BGP theory for Ibgp says that routers don't have to be connected directly, right? Routers do not have to be connected directly. So how are we going to form full mesh? Full mesh is an scenario where the router would be virtually forming neighborship with the opposite router. So let's say from this router point of view, though it's not directly connected, we have to virtually configure a full mesh. Okay, so there will be a neighborship between these two, and similar way there will be a neighborship between these two, and that is when the network behind will get advertised to the other routers. Okay, well, so that was a short introduction about full mesh. Now, what is route reflector, or why do we need reflector? The reason is, in the case of full mesh, I'm just gonna create neighborship with each and every routers. Okay, so let's say I have 10 routers. Okay, I have 10 routers. I'm forming a neighborship with all of the 10. So basically I'm increasing my advertisement. Okay, that's not very good in case of in the BGP. Okay, if let's say you have uh, 10 20 BGP routers, might be you have to form neighborship with all of them. Okay, so to rectify that, to avoid that uh, drawback, we make use of route reflector. So in case of route reflector, I will have a route reflector server which would be connected directly with the uh, clients, and the client has to form neighborship with the server. Okay, the client and the second client don't have to be neighbors in case of IBGP. So basically what happens in route reflector is client 1 will form a neighborship with server. Similar ways client 2 will form a neighborship with server. Okay, and whatever networks you have behind, they are gonna get advertised with the help of route reflector. And route reflector is one which is used in the production, not the full mesh, because in the case of full mesh, if I just go with the default theoretical concept of IBGP, then I'm not gonna have a complete synchronization or a complete advertisement synchronization. I need to get my full mesh. So full mesh is something where all the routers are just connected to each other. Okay, so might be they are directly connected or they are virtually connected. It doesn't matter. They have to be connected. So your network advertisements are increasing. So this is not preferred. Okay, the main thing that we use in the production is route reflector. Well, so that was a quick introduction about full mesh versus route reflector. Now, why do we need this? That's important topic now, right? Why do we need full mesh and route reflector? We can just go with the normal IBGP configuration, and we can just uh, do, or we can just configure the normal BGP, right? So the thing why we use these two mechanism is to avoid looping inside internal BGP. Okay, so we have gone through eBGP. Okay, and I told you in case of eBGP, the loop prevention happens because of AS path attribute. Every prefix are gonna get associated with a AS path. Okay, so this is how in the case of eBGP the loopings can be avoided. How about in IBGP? So in IBGP, let's say I had networks behind this router, and let's say if they are all getting advertised. Okay, let's say even this router is gonna know what is the network behind this. So basically there is a chance that they create a loop. Okay, so what IBGP does by default is it's gonna remove those networks. Okay, so by default what IBGP is gonna do is whatever network or whatever prefix you're advertising, that's gonna remain just within these two. Okay, so this router will not know anything about this network, the network that we are advertising, right? So that's a default mechanism in the case of IBGP. And let's say we need to know what is a prefix behind this. So in that case, I go with two options: full mesh or route reflector. In the case of full mesh, you just need to connect all the routers, even though that's not a prerequisite for IBGP. IBGP says router don't need to be directly connected. Okay, router can be on any corner and we can just connect them and configure IBGP. But only thing is they will not know the complete database of the prefix. Okay, so to have that we need to form full mesh or route reflector. Fine. So that was a short introduction about this topic. So let me quickly go with the lab. So I have full mesh, okay, over here, and I'll be showing you the route reflect over here. So this is a new data center, and I just considered it to be Sao Paulo. Okay, and all the IP addresses are labeled. So what I prefer is, so say for example, this is router 22 and this is router 23. So you see how is my subnet being associated. I go with 23 to 22. Okay. Similar way, when I have 22 and 24, you can see my IP structure. So it's just to have a simplicity, or to just know the packet flow, because it becomes very easier while analyzing the packet when we follow some structure. Okay. So I keep those numbers, the router number as my second and third prefix. It makes a little easier for me to demonstrate. Okay. So that was regards to IP address and the design. So let's say I open up these devices, or I take the console of each one of them. Okay. So I'm just gonna reconfigure them. I'll just put it on reload, and same thing over here, so that I can do it from scratch and you guys can follow me. Oops. So looks like my GNS went into bug. So I have to close and reopen this. So it happens frequently with GNS client. I heard GNS have their web GUI with very advanced option. So need to check that. So route reflector is about server client relation. Okay. Whereas full mesh is like you need to have all connectivity. Okay. It can be physical connections, or it can be virtual as well, but there should be a full mesh. All right, so let me open it once again. So we are almost done with the BGP topics, guys. Might be I'll take one last class tomorrow, and then we will start with some other topics. Okay. So we are going to end the BGP topic from CCNP point of view. Okay, so let me power them on. Let me take the console. Okay, so I have Sao Paulo 22. This is Sao Paulo 23, router number 23, Sao Paulo 24, and Sao Paulo 25. Okay, so the first four of them. So as usual, we configure the IP addresses. Okay, so I have the IP address over here, and let me show you the IP address first. Well, so I have all the IP addresses with me. And the fourth router. Okay, so as of now I only have IP address. So let me see, do I have anything for BGP? No, I don't have anything for BGP. Okay, that's something which we are gonna configure now. And if you guys wanna help me, you guys can also contribute. Okay, so that's all left to you guys. Okay, fine. So first I'll start with Sao Paulo 22. I go to router BGP. I define the AS number. So the AS number is this 23,000. I define the neighbors. So I am having a direct neighbor here, 209.2322.1, and I'm gonna define the remote AS. So they are IBGP, so the same AS values. So Sao Paulo router 22 is also having a second neighborship with 209.22.24 and 2. Okay, and remote AS of 23,000. Let's define the networks. So basically they are a /30, which is 255, 255, 252. And there's also another network which is 209.22.24.0. Okay, so basically what I'm trying to do now is I'm having the BGP neighbor between these two router, and I'm advertising those networks. Okay, a very simple IBGP configuration. So I go to the next router, that is 23, and I do almost the same configuration. Router BGP 23,000. So my two neighbors here are 209.2322.2, remote AS of 23,000. And on the second side, I have the neighbor with 209.23.25.2 and remote AS of 23,000. Let's also advertise the networks. So it's 22.0, mask of 255.255.255.252. And on the second side, you have 209.23.25/30. Okay, fine. So I did a configuration. So I did configuration on 22, 23. So I'm left out with 24 and 25. So I go to 24. I say router BGP 23,000. I define the neighbor. It's 209.2224.1, remote AS of 23,000. On the other side, I have 209.23.24.1 and remote AS of 23,000. Now let's define network as well. So mask of 255.255.255.252, and on the second side I have 23.24.0 and mask of /30. Okay, fine. The last router over here in this scenario. router BGP 23,000. Neighbor statement first. I have neighbor with 209.23.25.1, remote AS of 23,000. And the second neighbor here is 23.24.2. Okay. And the network statement 209.23.25.0, mask of 255.255.255.252. And on the second side, the network is 209.23.24 and mask of /30. Okay. So this is a normal IBGP configuration. Fine. So let's see the tables first. Let's see what are my tables. So I see the BGP tables from Sao Paulo 22 point of view. Okay. So from this router or this router point of view, I can read this prefix 22.24. That is nothing but this. Okay. They are directly connected. I can also read 22.22 or 23.22. Fine. I can read 23.24. Okay. And I can read 23.25. Fine. That's great. That's expected because they are directly connected and they are just being advertised. Now, what if I have a network over here? Okay, so let's say I have a network behind this. Can I still see that network either on this or over on this? So let's check it out. Okay, so what I do is I go to the 25th router, Sao Paulo 25th router, and I configure some loopback address. So let's go with loopback 25 because just to match with the router ID. So I say IP address of 255, sorry, 25252525 and subnet mask of /32 255 255 255 255. Okay, no shutdown. And also advertise this inside the BGP process. Okay, it's 23 that I have. So I'm gonna advertise this network, and I'm gonna say this is the subnet mask. Great. So first, let's see if this network is getting recognized with the directly connected neighbors. Okay. So here in my case, the directly connected neighbors are 23 and 24. So let's check it out on 23 and 24. So on 23, I do see. Okay. Let's check it out on the routing table. I do see. Okay. Let's give a ping. So they are reachable. Okay, so from 23 it's reachable. What about from 24? Yes, it's reachable. I do see. Now let's check it out from 22 point of view. Okay, from the router 22 because it's not directly connected. And let's see what is by default IBGP gonna do. So if you see, you will not see any prefix reading out to be 25, right? Because that is a default behavior of your IBGP. What is IBGP doing? IBGP is trying to not advertise the prefix of this over on this because they are not fully mesh or they are not directly connected. Okay. So what is IBGP doing? IBGP is advertising to the neighbors, and the neighbors are gonna keep that 25 series network within themselves. Okay, they're not gonna send or they're not gonna advertise 25 to this router. And now that's a circumstances where I need to bring some mechanism, and the mechanism is in front of you, either full mesh or route reflector. So we are first dealing with full mesh. So I'll show you the full mesh configuration. Okay, so in the case of full mesh, what I need to do is I need to virtually make a neighborship between these two. Okay, same thing goes with respective to these two router as well, because they are not directly connected. So any network that this router is advertising will be only uh, retaining, or is only gonna be recognized with these two routers only. So this is not gonna understand what are the networks behind this router. If you guys want to see, I can do that. So I go to Sao Paulo 24. I create a loopback address. Let's say loopback of 24. I say IP address of 2424 and subnet mask of /32. And now I advertise this in my BGP 24242420 and mask of 255.255.255.255. Okay. So let's see on the adjacent routers first. So 22 is one of the adjacent router. So is the loop back up? Let's check once. Okay, so it's up. What about on 25 router? Let's give it a try. Okay, so you can see okay, so 24 is missing. So let's check it out. Where is 24 getting advertised? So you have 24 here. Do show IP summary. All right, so I have the network statement. Did I miss anything by chance? All right, so let me give a check on that. Okay, might be, yes, I have done a mistake in the subnet mask. Do show run interface loopback 24. So it says /32. Okay, so I have given a mask of so this is a wrong mask. Okay, so let me tell you how does it should be. So it should be the direct IP, not 0. If I give 0 and if I give /32, then it's that particular IP that's getting advertised. Okay, it's because I'm making use of a /32 network, and in case of /32, this is a different IP, and 2525250 act as a different IP. Both of them act as a different IP. So I must remove this statement and I must put 24 here, and that will fix this. Okay, so let me say this is no, and let me fix the typo. Okay, great. So let's see on the adjacent routers on 22. Yes, I can see the network now. Okay, so Sao Paulo 22 and Sao Paulo 25 must have the prefix of 24 series. Okay, so we do have. What about Sao Paulo 23, which is opposite router? So by default, these are not gonna advertise anything about 24. So we should not be seeing anything for 24 on this, right? So we don't see anything for 24. So that's something default behavior of internal BGP. The routers are not gonna advertise. So we bring the full mesh concept. So what I'm going to do is I'm gonna virtually form a neighbor. So remember important point here. So let's say you're forming a neighborship over on this direction. Okay, do the same, follow the same direction while forming neighborship on or from the opposite router. Okay, because you might do a small mistake here. Might be you take consider this path, okay, while configuring from 22 to 25, and while configuring from 25 to 22 you might consider this. Now that's a wrong configuration. Okay, so you can have neighborship on this direction. Okay, 25 to 22 or 22 to 25, you can have this. Otherwise you can follow this direction. Okay, north to south and south to north. But you cannot have two different things, or you cannot have asymmetrical things here, like from 22 to 25 you follow this, and for 25 to 22 you follow this. Now this is not going to help you. Okay, so make a point of this configuration. So I'll tell you what I'm going to do now. So on router 22 I say neighbor, and this is my neighbor now. Okay, I'm going with this direction. Okay, so I'm forming neighbor with this, not with this. I'm not taking up this direction, so I just take this direction. Okay, so let's say neighbor of 209.23.24.1 and remote AS of 23,000. Okay, just one single command from router 22 point of view, and the same command goes good with the southbound direction. Okay, that means I must also configure the similar virtual BGP configuration from 25th router. So I say neighbor, what is a neighbor here, 209.22.24.1 and remote AS of 23,000. Okay, so before doing that, what was missing? It was 25 that was missing, right? So you see there is no 25 as of now. So let me make them full mesh. Okay, so when I make a full mesh, we should be seeing a update packet being transported. Okay, so this is the update packet that's gonna take the information of the additional route and the parameters that we configure. Well, so it says BGP is up now. Okay, and let's verify if I have 25 series of network now. So you can see it's been read. Okay, so I can read the 25 series network because I am forming a full mesh between these two routers. What about this now? Having one full mesh will help me? No, that's the biggest drawback of full mesh. Okay, it's not that I have one copy of full mesh and all of them start uh, acting differently than the Ibgp concept or the default concept of Ibgp. Okay, the drawback of full mesh is you need to have full mesh with every opposite routers. Only then that's gonna get advertised. Okay, so if you see now on 23, you will still miss the 24 network. See, you don't have 24 network because you don't form any full mesh between these two routers. Okay, you don't form any full mesh, so that's something which I'll do it now. Okay, so I'll follow this direction. Let's go with this direction. So I'll form a neighborship between this and this IP. So I say neighbor 209.22.24.2 remote AS of 23,000. Okay, one single command. And from the opposite side, I would say neighbor statement of 209.2322.1 remote AS of 23,000. Okay, and yes, I can bring the update packet. So I have update packets ready with me. So let's give it a try. Okay. So you can see there are a couple of messages, open messages, route refresh, update packets. Okay. So what is update packet carrying? So it's carrying the information about 209 and 209.25. Okay. What about the second packet? And do you see the new network getting advertised now? So your update packet is carrying the new update. Okay, or the new packet. Okay, so let's see if I can read the new networks. Okay, to show IP BGP. So I have both of them, 24 and 25. So for 24, okay, so let's see on 23 now. So on 23, do I see the required number? So I see that. Okay, I can see a full mesh now. That's between these two. Okay, so this forms a full mesh, but this is not a the best practice. It's not a best practice in the environment, because the more prefixes you have, or the more number of IBGP you have, you need to form a complete full mesh. Okay, so if you have like 10 BGP speaking routers, then you will have 10 uh, full mesh numbers. So that's actually not a good practice. So we try to avoid full mesh. Okay, and the second option here to just come out of that IBGP concept, that's to advertise um, all the non-directly connected routers, we go with route reflector. Okay, and route reflector forms a server client relation. So one of the router is acting as a server, and the two different clients have to form BGP neighbors with the server. Okay, so I mean to say, so let's say I have a server here, and this server has to be directly connected with the clients. So it can connect to multiple clients, it doesn't matter. Okay, so the server will be directly connected with the clients, and they have their own BGP peers. Now let's say this router wants to talk to this router. Okay, so they cannot go directly, or they cannot communicate bypassing route reflector. So whatever communication happens have to happen over on route reflector. So this router has to send it to route reflector, and route reflector will pass it on to the rightful routers, or the BGP router. Okay, so let's do the configuration, and for this I have three different routers. One is called as Sao Paulo 23. So let me give it a different name. So let's say this is a route reflector, okay, or a server, just for our easy reference. And the rest of two are clients. So let's see if I have the IPs. Okay, I got IPs. I have one IP because only one physical IP which is connecting to the route reflector. Okay, no more networks. Okay, and one more from the second client point of view, that is from this. So only one interface that's configured. Well, so let's configure the normal IBGP. So let's say I go to conft, I go to router BGP 23,000. Since I only have one neighbor and the neighbor IP is this, okay, I'll just copy this and put it here. And I say remote AS is 23,000. Network is /30 252. Okay. So let me also configure the second client and then I'll go to the route reflector. Okay. So I go to the second client. I say router BGP 23,000. My neighbor is with this IP. I say remote AS of 23,000. Okay. I define the network 255.255.255.252. Okay. Okay. Now time to configure the Sao Paulo 26 router. So first I'm just gonna do the normal IBGP. Okay. I'm not gonna configure route reflector. I'm just gonna show you the uh, normal IBGP configuration. So I go to router BGP 23,000. I go to the neighbor statement and I first form neighborship with this IP. Okay, it's a 23,000 remote AS. And I'm gonna define the network 255.255.255.252. And on the second side, I have this IP acting as a neighbor. Okay, so I say neighbor with this IP and it's on this autonomous system. And the network to be advertised is this. Okay, so let's see the BGP neighborship first. So the client number 1 has a BGP neighborship with the 26 or the center router Sao Paulo 26. Okay, only one neighbor. It's not gonna form neighbor with the second client because that's the whole benefit of route reflector. So you're just uh, minimizing those neighborship. You're not forming multiple neighbors. You're not advertising a lot of things. Okay, you're just restricting having multiple neighbors. And from second client point of view, you can see that you will have only one neighbor, that's with the center router. Okay, let's try to ping each other. So let's say I have client 1 and I'm trying to ping client 2. Okay, so let's give a check by pinging the second client. So they are reachable. So that means from this router to this router there is a connectivity. There is a connectivity, but what about the prefixes behind this router, right? So that's of my concern. So what I do is I go to second client and I configure a loopback to just make sure I have the reachability or no. So let's say interface loopback and let's consider it to be 28 because that's the router ID. Okay, 28. Let's give an IP address of 28.20 28.28 25.255.255.255. I go to router process, router BGP process. I advertise this network, and I'm not gonna make a mistake now. Fine. So I have advertised this. So let's see now this newly advertised network is being recognized by this first client. Okay. And at the same time, is this network 28 getting recognized by the 26th router? So let me go to the 26th first. If I do show BGP, so I have the new prefix with me because I am directly connected. 26 and 28 are directly connected. So they are getting advertised. Now I just want to make sure this 28 is also gonna recognized by 27 or not. So by default, IBGP is not gonna do that, right? Because that's your IBGP definition. So this router is not gonna advertise anything about 28 to the client one. So I'm expecting the same thing. I should not see anything for 28. Okay. And yes, I don't have anything for 28. Now I don't want to go with full mesh. My project says don't follow full mesh. Okay. So I'm only left with route reflector. So what would be my configuration? So what I do is my server will say that I'm forming route reflector client relation with these two clients, and that's how they are gonna get recognized. So I'm gonna tell you what is the command, might be then you understand. So if I go back to my previous neighbor command, okay, that's this one. Okay, so neighbor 209.27.26.1, that's on the first side. Okay, so I being the server, okay, I being the server, I'm gonna tell that this client and myself are forming a route reflector relationship. Okay, and that is something what I'm gonna configure here. So I'm gonna say this neighbor act as route reflector client with me. Okay, so I'm defining my client. If they are not being defined, then they are non route reflector clients. Okay, they are called as non client. If they are being defined with the help of this keyword, then that client and myself being server, we form a route reflector server client model. Okay, so I say yes. And on the second side, I also have the second neighborship, that is 28.26. Okay, 28.26, and I do the same thing. I say this is a route reflector client with me. Okay, two additional commands. Now let's see what happens once you configure that. Do you see 28 network here? Okay, and you can see the new you can see that 28 series network is being recognized now. So basically what is happening, this client number 2 is advertising it to 26, and now since 26 is acting as a server will take the responsibility of distributing this routes or this prefix to all its client. Okay, so client and client will not talk to each other. You don't have to have a full mesh between different clients. It's just that you have to push it to the server, and server will take it forwarded. Okay, so server in this case is sending it to client number 1, and that's why you have the 28 series network here. If I do show IP BGP summary, I have one neighborship with my server. Okay, and inside my routing table, I can see 28 series network. If I do show IP route 28.28.28.28, So it says that it's been learned on BGP 23,000 AS value, and this is my next hop. Okay, so let's give a ping test. Sorry, I have to add do. Okay, and they are reachable. Okay, so this is about the loop prevention mechanism, or this is how the split horizon in case of BGP is taken care. Okay, so we have made use of split horizon while discussing EIGRP. Okay, a distance vector, and in the case of BGP also we make use of split horizon in the case of IBGP. Okay, in the case of IBGP, if someone asks you how is split horizon being taken care, so there are two methods. One is full mesh or route reflector. Okay, and in the case of BGP eBGP connections, you have AS path taking care of the split horizon. Okay, what about in case of OSPF? Do we see the split horizon in the case of OSPF? Yes or no? And if it is yes, then how do we fix? If it is no, then how do we say no? So do you guys think in OSPF we encounter this looping issues, or do we bring up this split horizon concept in case of OSPF? Yeah, so in case of OSPF there is no split horizon. Okay, the reason is OSPF is a link state vector. Okay, so what is link state actually about? It's another way of a full mesh, right? What is full mesh? Full mesh is you have a neighbor connection with each and every router in any corner of your environment. Now in the case of OSPF, since it's a link state vector and your OSPF database is gonna have all the n number of uh, routes, so it's basically like a full mesh connection, right? So you're already having that inbuilt algorithm to take care of looping in case of OSPF, which don't have in the case of EIGRP and in the case of BGP. That's why we make use of uh, some kind of mechanism to avoid split horizon in these protocols. Okay. In case of OSPF knows each and every linked database because LSAs get generated. LSA will carry all links information. So it knows that so and so is the network uh, over here, and it's gonna avoid looping. But in the case of the other protocol, you need to have some mechanism, and in today's class we read about BGP. How do we avoid these looping in the case of IBGP, internal border gateway protocol. Okay, so well, that's all from my side for the for today. I don't want to include any other topic. So the next topic will be in the next class. Okay. So let me take your Q&A. Let me know if you guys have any doubt. Okay. So you want to see this command. So what's that command actually? It's show BGP. Okay, so let me take a prefix of 28282828. 28, 28, 28, and 28, and there are options like best path and multi path. Okay, show IP BGP. So let me get the neighbor first. It's this. Show IP BGP neighbor advertised. Okay. So this is your network that's getting advertised. 26.30 next hop. And the reason for next hop 00 is because they are within a single AS. Okay, that the route is learned within this. So basically, this network is directly connected. So you can see here 209.27.26 network is a local network. So that's why you see next hop to be a 0, and this is an indication of a local route. Okay, so that's a different configuration when you have a soft reconfiguration. Okay, so when you bring this configuration, you can see received routes. So this is a advertised route, and the same command, if I give it on the server, show IP BGP neighbor advertised route. So you can see the client number 2 is advertising these 3 networks, and at the same time, when you have 28.26.1, so you can see these are the 3 networks that server is advertising towards these neighbors. Okay, or else you can also see it from so this is a BGP learned route, and the others are the directly connected. So basically this server is advertising 3 different networks. Okay, so you see this is having a different next hop because they are behind the client number 2. Okay, and the route within themselves will have the next hop with this indication. So you can see the weight is itself says that it's a locally learned. So you have 27.26 on one side and 26.26 28.26 on the second side. So this is a uh, so this is a route which is behind another router, or we can say that this router is learning this from this next hop. Okay, 26.1, which is nothing but from this router. So guys, I'll give you all the configurations, running configurations, and uh, the show commands, and you guys can practice it during the weekends. Okay, so that's all from my side, and if you guys have no more doubts, so we can meet up in the next class with a new topic. Okay, so have a nice day, see you soon, and I'm just winding up for the day.